Hello everyone, welcome back to my daily Leetcode channel. So let's try to Swift it. We are trying to solve everything in Swift for straight after 22 days after the long break. So today will be the 23rd day of my daily Leetcode problem. So daily Leetcode problem is the minimum cost of buying the candies with discount. So a shop is selling the candies at discount. For every 2 candies sold, the shop gives away that candy for free. The customer can choose any candy to take away for free as long as the cost of the chosen candy is less than or equal to the minimum cost of the 2 candy bought. For instance, if there's 4 candies which costs 1, 2, 3, and 4, the customer buying candies with cost of 2 and 3, so the customer could get the candy with cost 1 for free, but not the candy with the cost 4, because 2 and 3 combination will be 5. Okay. Okay, makes sense. So we are given a zero index integer array cost, where each of course instead denote the cost of index candy. We have to return the minimum cost of buying all the candies. Let's check the XML first to understand how it works. So we have given like 1, 2, 3 candies. Okay, we need to check the condition. Okay, a customer can choose any candy to take away for free as long as the cost of choosing candy is less than or equal to the minimum cost. Alright, so in here we can buy the candy with the cost of 2 and 3 and take the candy with cost of 1 for free. So the total cost of all candies is 2 plus 3, and there will be 5. And then the only one we can buy the candies, but we cannot buy the candy with the cost of 1 and 3. Then take the 2 for free, because the cost of free candy has to be less than or equal to the minimum cost of the purchased candy. So we can see that if we buy the candy 1 and candy 3, we can take away the candy 2 for free because our minimum candy price is 1. How about we buy the candy 1 and candy 2? That's also not possible. We cannot check the total because the minimum of the candy price that we buy is 1, and we are not allowed to take away the candy price 3 for free. So that's why we choose 2 and 3. Minimum is bigger than 2, and we can take away the 1 for free. How about example 2? I think this can be easily solved by using the one of the sorting algorithm. Let's consider that we sort this. We can take in the huge number first, 9 and 7. We get the 6 for free. Of course, 9 and 7, we got the 6 for free because our minimum began the 7. How about 5 and 2? We got the 2 for free. Right, 5 and 7 is 7. 7 multiplied by 2 is 14. 14 plus 9, 23. Alright, got it. That's how we receive the answer. And if the cost is, what if only 2 items, only 2 candy in here, so we cannot take away anything. Alright, I think that's a pretty standard Leetcode greedy algorithm. Not a greedy, it's a greedy algorithm. Easy question because the constraint of the cost range is from 1 to 100 and the cost is within 1 and 100. I think we can solve it easily by using the greedy algorithm. Let's try to sort that first. Maybe sort dot reverse because we need the sorting in descending order, or we can use like sorting by descending. that will be reset, and then we need a one variable called reset to keep track of our total amount of the candy cost, and we can iterate through like 0 to, I don't want to do the cost.count, let's do it like count, and then what we can do is maybe just do the same mathematics in here. Let's consider if index is of the remainder is not equal to 2, we will append the reset with the reset of index, and then we can just return the reset here. Not sure we still need to do the break or not. What did I do wrong? Oh, it should not be the reset, it should be the cost, because there is no index in the reset. Alright, let's try to submit. I think the, oh, nice. The time complexity will be the O of n log n, because we use a sorting algorithm by the Swift, which is O of n log n, and the space complexity will be O of n, because we have one array that's use exactly the same size at the given array, just to sort that out. Alright, I hope you guys enjoyed that easy problem, and see you in the next one. Bye.